Hi everyone, welcome back to lesson 2.3 where we're going to talk about lines. Specifically, we're going to talk about slope, which formally is just the average rate of change. It's how much y is changing as x is changing. We can also think of it as the steepness of a line. So think about in life, you've got mountains, hills, things that have slopes. We would look at the steepness of those slopes. And on a line, the slope remains constant, so it doesn't change. To find the slope, we're just going to take two coordinates on the line, any 2 points you want, and one of those points will be x1, y1, and the other's x2, y2, just as we saw when we were finding distance between 2 points or finding the midpoint between 2 points. And we're going to find the slope, which is the letter m, so think of m for mountain, by taking y2 minus y1, so the y's, how are they changing, also known as the rise, over x2 minus x1, so how are the x's changing, which is referred to as the run. So it's rise over run. It's also referred to as the Greek symbol delta y over delta x. So delta looks like a triangle, and delta just means change in. So it's the change in y over the change in x. What is the slope of a vertical line? So on a vertical line, you're always rising. You're not really running. So your run would be 0. And when you divide by 0, it's undefined. So vertical lines don't have a slope. Their slopes are undefined. For horizontal lines, you're running, but you're not rising. So your rise is 0 over your run, and 0 over anything is just 0. So the slope of a horizontal line is 0. An easy way to remember this is no, 0's on the bottom, it's undefined, and it's okay to have 0's on the top. It's just 0. Okay, so let's practice finding the slope. So here's my 2 points, 4, 2, and 3, 4, which you could graph. They would be in the first quadrant, but I don't need to do that. I'm just going to label x1 and y1 and x2 and y2. And to find my slope, m, remember it's y2 minus y1 over x2 minus x1. And 4 minus 2 gives me 2, and 3 minus 4 is negative 1, and 2 divided by negative 1 is negative 2. So my slope there is negative 2. So what exactly does that mean? So slope should always have a rise and a run. So if I was to put this over 1, I could take that negative, and it doesn't really matter. I could move the negative down with the 2. So what this means is every time I'm rising 2, I'm actually running left 1. So it's going to give me a negative slope, which would be a line that's decreasing. And all along that line, you're going to be rising 2 and running 1 to the left. Or you could fall 2 and run right 1, and you'll still end up on that line. A couple properties or things that you'd want to pay attention to about equations of lines is that two special kinds of lines, vertical lines and horizontal lines, they're going to be written a little bit differently. So remember, a vertical line won't have a run, right? You can write the equation in the form x equals the x-intercept. And then for horizontal lines, it's going to be in the form of y equals whatever the y-intercept is. And typically we refer to the y-intercept as the letter b. So let's look at those two examples before we look at number 3 and number 4. So here's an example of a vertical and a horizontal line. So if you'll remember, the x-axis is your horizontal and the y is your vertical. But if I want to graph x equals 3, I'm going to go on the x-axis and I'm going to find where it's 3. Okay, is that the only place x is 3? No, all along this vertical line, x will be 3. So if I want to graph x equals 3, it's just a vertical line through that x-intercept right here, x equals 3. If I want to graph y equals -2, I'm going to go on the y-axis now and find -2, and I'm going to draw a horizontal line through it, because all along that line, your y value is the same. Think of it as the same height. It's all along -2 on the y-axis. So again, that's your y-intercept right there. So there are two special forms of equations. And remember, the slope of a vertical line is undefined because we're not running, we're just rising. And for the slope of a horizontal line, the slope is 0. It's flat, right? Think of it as like if you're skiing across a surface and you ski over a horizontal flat line, you have 0 risk of getting injured, right? Okay. So now in the next problem, I need to find the slope and the y-intercept. They're not given to me. So if we go back up and look at equations of lines, number 3, a special type of or form of an equation of a line that we can write is y equals mx plus b. So remember that m is the slope and b is the y-intercept. So we're going to use this form to graph the equation when we know the slope and the y-intercept, the m and the b. In this problem, we have it written in standard form, which is ax plus by equals some number c. So I need to take the standard form and turn it into y equals mx plus b. So I'm simply going to just solve for y. I'm going to get the y by itself. So if I take my equation and solve for y, I'm going to subtract 2x. So I get 4y equals -2x plus 8. And then I'm going to divide by 4 and just simplify. So I would get y equals -2/4 is -1/2 x plus 8/4, or 8 divided by 4 is 2. So now I can pick out my m and my b. So remember, the equation goes y equals mx plus b. So my m is the coefficient of x. It's the number attached to x. And then my b is the y-intercept, and that's your constant at the end. So my m is -1/2, and my y-intercept is 2. If you would like to graph that equation, there's two things you could do. So an easy way to graph this. Step number 1, you're going to begin at b. Step number 2 is you're going to move with m. So remember, m is your slope. So you're always going to rise. Then you're going to run to the right if the slope is positive. You're going to run left if your slope is negative. So for example, in this last equation, I'm going to begin at b, which is my y-intercept. My b is 2. So I'm going to put a dot right on the y-axis at 2. Now I'm going to move with m. So what's my rise and what's my run? My rise is in the numerator on the top, and my run is in the denominator on the bottom. So I'm going to rise 1 from that purple dot that I have there. I'm going to go up 1, and then since it's a negative, I'm going to run to the left 2 times. So from that first purple dot, the y-intercept, if you go up 1 and left 2, now you've got your line. And then lines, remember, have arrows because they go on forever. In the next problem, we want to find the equation of a line given 2 points. So anytime I want to find the equation of a line, I need 2 things. I need m and I need b. Okay, So I'm missing m, I'm missing the slope. So I need to find the slope. So that's step number 1. So I'm going to do y2 minus y1 over x2 minus x1. And I get 2 over negative 6, which reduces to negative 1/3. So there's my m. Okay, and ignore that box right there. The next thing I need to do is find b. So in order to, there's a couple ways you could do that. You could plug numbers into y equals mx plus b, or you can use another type of equation, which is the point slope formula. So we use that when we have a slope, which we just found, and one point that we could plug in. And then we can work backwards to write our equation in slope-intercept form. So I'm going to, for step number 2, I'm going to use the point slope formula. Y minus y1 equals m times x minus x1. Because I have the slope, I have m, and I also have a point. You can pick any one of those 2 points. I'm going to pick 2, 3 because it's positive and they're smaller numbers, so they're easier to substitute in. And now I'm just going to plug some numbers in. So I've got y minus y1. So y1 and x1 are the point that you just picked. So y1 is 3. And my m is negative 1/3 times the quantity x minus your x1 is 2. And now all of this is just algebra. You're going to solve for x. So I'm going to have to distribute the negative 1/3 into the parentheses. So I would get negative 1/3 x, and then negative 1/3 times negative 2 is positive 2/3. And I need to write this in slope-intercept form, y equals mx plus b. So I need to now add the 3. So I would get y equals negative 1/3 x plus 2/3 plus 3, if you were to add that, is really just 3 and 2/3. And if I want to change that to an improper fraction, you would just multiply the denominator times the whole number, so 3 times 3, which is 9, and then add the numerator. 9 plus 2 is 11. So that's 11 over 3. And that is your equation of your line in slope-intercept form, which I can also write in general form, which I'm going to show you now shortly. So the general form of an equation of a line, we kind of talked about, I mentioned it earlier, is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0, otherwise they would not exist. X and y would cancel out. So these are known as linear equations. By the way, when you have an equation written in general form, so for instance, I could have taken this equation that's written in general form. One of the easiest things to do, rather than all this algebraic manipulation, if you want to graph that, just find the x and y intercepts and graph that way. A lot of times that's easier. Okay, and we'll see that here below. So here's an equation in general form. Okay, and what I need to do is I need to find the intercepts. So remember, to get the x-intercept, you're going to let y equal 0 and solve for x. And to get the y-intercept, you're going to let x equal 0 and solve for y. And now I'm going to plot my 2 points. So 2, 0 on the x-axis, that's your x-intercept. 0, negative 3 on the y-axis, that's your y-intercept. And then draw your line. For the next equation, I need to write an equation of a line that passes through the points negative 2, 3, 4, 5, and then write the equation in slope-intercept form and general form. So this is good practice. So the first thing I need to do is find the slope. So I got 1/3. Now I've got a slope and I have a point, and I can plug those in to my point slope formula. And I'm going to distribute the 1/3 to the parentheses. And then I'm going to add 5 to both sides. So there's a couple ways you can do this, which is I was just trying to figure out an easy way to show you this. You've got -4/3, and we're adding 5, right? So you can't add those unless you have like terms, or rather like denominators, which I don't have. Okay, my like denominator is just going to be 3. So I'm just going to multiply that by 3. 5 times 3 is 15, right? 15/3 is 5. Now that they have the same denominator, I'm just going to add the numerators. So -4 plus 15, that gives me 11/3. Okay, so that's in slope-intercept form. I also need to write it in general form. Remember, general form is what we just talked about. It's ax plus by equals c. So I need to get the x and y on one side first. And then I need to take care of those fractions because a, b, and c are usually all integers. And the other rule is that a shouldn't be negative. It's okay if b and c are, but a is not. So I have to use some algebra here to move things around and change some signs. So the first thing I'm going to do is I'm going to subtract the 1/3 x. So you get -1/3 x plus y equals 11/3. And the next thing I don't want those fractions, and I don't want the negative for the a term. So to get rid of it, I'm going to multiply both sides by a -3. That's going to cancel the negative, and it's also going to cancel out the 3. So I'm going to multiply both sides by -3. -3 times -1 is 3, and 3/3 is 1x. -3 times y is -3y. And -3 times 11 is -33, divided by 3 is -11. And then that is in general form. We also need to graph. So graphing this, it would be easier to graph it. Again, you can find the intercepts, or you can use the slope-intercept form and pick out your m and your b. So my b is 11/3, and my m is 1/3. So where's 11/3? If I divide 11 by 3, I get 3 and 2/3. So I'm going to go up 3 and about 2/3 of the way on the y-axis. And then I'm going to rise 1 from that purple dot, and I'm going to run 3 to the right this time because it's positive. And I went too far. Back 1. So it should go right there. So again, I'm rising up, I'm beginning at 3 and 2/3. That's what 11 divided by 3 is, your y-intercept. That's where you begin. And then you're going to rise 1 and then run 3. And then that's going to be your line. Okay, 2 things you need to remember if you had geometry. When you have 2 lines in a plane that don't intersect, remember a plane's just a flat surface, like this is a plane, this coordinate plane. 2 lines that don't intersect that are in the same plane, we refer to them as parallel lines. And if I was to graph 2 parallel lines, they would have the same or equal slopes. However, when you have two lines that intersect to form a 90-degree angle, so they would make like a T, those slopes are not the same, right? One is vertical, one's horizontal. And they don't have to look like that. They could be slanted as long as they make a 90-degree angle when they intersect. So those would have what we call negative reciprocal or opposite reciprocal slopes. An example of negative reciprocal would be like if I took 2/3 and flipped it, that would be the reciprocal, 3/2, and then make it negative, so change the sign. 2/3 and negative 3/2 are negative reciprocals. Another example is let's say you had -5. What's its negative reciprocal? So it's already negative, so we're going to make a positive. And then the reciprocal, if we flip a 5 over, remember it's 5/1, you would get 1/5. So those are some examples of negative reciprocals. If I saw slopes that looked like that, I would know that they are perpendicular lines. And if I saw slopes that were the same, I know those lines would be parallel. Okay, so we're going to show that the lines given by the following equations are parallel. So what I need to do is I need to show that their slopes are the same. So I'm going to take each equation and I'm going to find the slope, and I'm going to do that by putting it in slope-intercept form. So I'm going to take the first equation and put that in slope-intercept form. So y equals mx plus b. Okay, and then you're going to pick out your slope. Your slope here is -2/3, and that's for line 1. For line 2, if they are to be parallel, their slope should be the same. So I'm looking to see if I get a slope of -2/3 for this line as well. If I reduce -4/6, I get -2/3 x. And then there is no y-intercept, it's just 0, right? You can put that if you want, but it's not necessary. Your m is -2/3. So since they both have the same slope, they are indeed parallel lines. The next problem says find an equation of a line that contains the point 2, -3 and is parallel to the line 2x plus y equals 6. Okay, so now we're writing an equation of a line. And remember, we need two things. We need m and we need b. So first I have to take my line that I have, 2x plus y equals 6, and I'm going to solve that for y and put it in slope-intercept so I can find the slope. So this one was pretty easy, right? Y equals -2x plus 6, and the slope is -2. So I need to write a line, an equation of a line that's parallel to that line, but it's got to pass through this point. So we have an m, and we have a point, a slope and a point. So you guessed it, we're going to use the point-slope formula. So now I'm just going to plug in. I have y minus. My y1 is -3. So be careful because it's already a minus sign there. My m is -2, and then I have times x minus x1, and x1 is 2. And now I'm going to clean this up, so two negatives make a positive. I'm going to distribute my -2, so I get -2, and then -2 times -2 is +4. And then I'm going to subtract 3 from both sides. So you get y equals -2x plus 1. So if I was to take both of these equations, okay, more specifically this one because it's already solved for y, which would be the yellow, and then let's say this pink one. If I was to plug them in to Desmos, you would see they would be parallel. So let's try it. Okay, so one of my equations was y equals -2x plus 6, so you can see that line. And then the one I just found is negative 2x plus 1. And you can see that the blue and red lines are parallel to each other. They have the same exact slope. Okay, for my next one, I'm going to do the same thing, except this time I'm looking for a line that's perpendicular. So I need to take my equation, solve for y, so here I would have negative 1/3 x plus 6 divided by 3 is 2. So out of there, I need to pick out my slope. But remember, your slope can't stay the same because we're not dealing with parallel lines, we're dealing with perpendicular. And perpendicular have to have opposite reciprocal slopes. So if it's already negative, I need to make it positive. And the reciprocal of 1/3 is 3. So this is the slope, that's the m that you're going to use when you plug it into the point slope formula. So now all I'm going to do is I'm going to take my m and my point and plug it into the equation. So you're going to have y minus negative 2 equals 3 times x minus 1. And then just clean it up and solve for y. So now if I was to take this equation and this equation and graph them, you would see that they would be perpendicular. They would form a 90-degree angle when they intersect. So we've got negative 1/3 x plus 2. There's your one equation. And then it was 3x minus 5. And those two lines, you can see they intersect each other. And if you were to measure the angles, okay, if I zoom out, maybe it would be easier to tell, they would form a 90-degree angle in the center. Okay, I believe that's the end of lesson 2.3. The next one will be 2.4 for circles. Hope you all enjoyed. Please make sure you work on your homework. If you have any questions, please reach out.